Welcome, everybody. Thanks for joining this afternoon sessions here at KCD Munich. Before we start with the actual talk, I just need to do two organizational announcements. The first one is the unconference. So I got asked to put this slide on this picture on the slides, right? So these 4 talks are accepted at today's unconference. So yeah, if you're interested about platform engineering, you can stick here for the next call and the next talk, and afterwards could go to the unconference, and also something about CNCF tags, chaos outages, and open telemetry. It's the first announcement. If you want to make a photo, else I'm gonna remove it from the screen. Let's see, we can do it. Yes, let's move it. We're going to full screen again. Perfect. Second organizational announcement is sadly Anais couldn't join. She just started her new job at JP Morgan and has not yet received her speaker clearance. So yeah, it's super unfortunate, but yeah. I hope I'll be able to bring her part as good around as she would have. So, having said that, I want to start, about rethinking package management in Kubernetes with Helm and Glasskube. And I want to start with a quick question. So, everyone, please raise your hands. I'm going to do this as well. So, who in this room really loves Helm? Makes sense? So, managing and like applying templates to manifests makes life easier, putting the Helm charts on the right. So a lot of our people here love and like Helm. And the second question, leave your hands open. Who in this room hates Helm? It's even more. Oh, perfect. So a little bit about myself. My name is Philipp McGlinson. I'm one of the co-founders of Glasskube. Previously, I studied computer science at the Vienna University of Technology, and then built up an alerting company for firefighting organizations in general, big corporates based in Austria. 2 years ago, we actually said, okay, maintaining high available infrastructure on Kubernetes across multiple countries and data center makes fun, but let's start the open source journey, let's start a startup. It's 2 years ago. We recently got accepted into Y Combinator, which is an American incubator program, and have been like trending on Hacker News over the last weekend. So yeah, now it's really ticking off, but it's not about me, right? It's the whole team, the whole company that stands behind me. And for every talk I give, I want to really put a shout out to the guys who are not standing on stage, but doing actually incredible work, taking care about our customers, users, open source enthusiasts, and yeah, because building up a team culture is super important. At the moment, we are not hiring, but yeah, let's keep an eye open. Hopefully, we can hire soon. And it's not about our team, our core team. It's also about the community. Super active community over on Discord. 170 people help our users, each other, if they have some general questions about package management, about Glasskube, or just want to mingle around. Not about Kubernetes. And these guys are actually so awesome. They are giving like talks all over the world by themselves, right? So Balakshan from India presented at a huge conference in India. Hanshal also has some meetups, so we're seeing Glasskube getting spread all over the world. But, right, so when we first started out with Kubernetes, we all think, right, it's a super nice grass, sunshine everywhere. We can hold Kubernetes in our hand and we're done, we're ready. We can really put our applications onto Kubernetes. But reality is kind of different. So we all know, yeah, once you really see what Kubernetes is, there are so many applications, so many third-party stuff that come down and that really bring you down to reality and say, oh no. Yeah. We also need to understand all these tools before we can actually deploy our stuff there. And how, I mean, I think we already saw this exact quote from Abdel in his keynote from Casey Hightower. So Kubernetes is a platform for building platforms. It's a place to start, not the end game. And I think this one never gets old. It will just be more accurate. And also, as we learned in the keynote from Abdel, I mean, we're trying to abstract these platforms from time to time and make it even more easier, because previous abstractions just get too complicated. So what does a platform? Just a quick note. Developer writes tools and infrastructure to streamline the development and deployment of applications. And most of the platforms actually really focus on the core applications. But what about platforms for all these growing packages in the CNCF landscape, right? There's like, I think, I don't know, 700 or even more applications listed here, and it keeps on growing. So the landscape gets bigger and bigger every day. And how I explain the role of a platform, which we also can call a package manager for third-party applications, is it like a DevOps sandwich. And the bottom layer, there is like Kubernetes. And this is like managed by all these cloud service providers, hyperscalers out there. I think some of them are also sponsors. And they're really taking care of managing Kubernetes. Or if you're on-premise, you have like partners like all the big companies or corporates providing you managed Kubernetes in one form or the other. And on the top, it's like your core application, which you have a platform team, a lot of developers who really make sure your core application gets deployed and managed in your Kubernetes cluster. But what about all the packages in the middle, right? The mix inside a burger, which is sometimes meat, sometimes cheese, something lecture, all this stuff. Who takes care about this? And about this part in the middle, which often is kind of messy, gets focused on by a package manager. And what tools are available as of now to manage these kind of packages? For sure, we all started with kube control, can deploy manifests directly to the cluster, and then Customize came up. A tool we're going to explore in the next couple of slides, which is now merged into kube control, so really you're like one of the default tools. Then obviously Helm came up. Kubernetes is now 10 years old. Helm is already 9 years old. And then we also have some new emerging tools giving like interesting approaches. Stefan Prodan, one of the maintainers of Flux, came up with Timoni, and also we with Glasskube try to abstract it and make it even more simpler for us to really take care about package management in Kubernetes. So what's the state about Customize? Customize, I think everyone in this room knows it. If you have your base manifest, but want to apply different versions, for example, different environments, or different customers, different clusters, different teams, and you don't want to duplicate your whole manifest, you can just write some patches and then apply these patches for specific environments. In this example, we have the staging or the production patch for your Customize deployment. But is Customize the right tool for packages? I'm not sure. One of the packages out there still like favors it as an installation method is the guys from Crunchy Data. They are doing a Postgres operator, and I mean, I have really mixed experience with the Crunchy Data Postgres operator. I hope nobody in the room works for them, but they work in a kind of a way where it's kind of open source. They give you the images, but the images you need to use inside your Kubernetes clusters are used from a private registry. And if you don't upgrade the operator and respectively the base images for your Postgres database, they will from time to time make older Postgres images private. And when you then have to reboot a node or want to restart your Postgres database, and the image is not yet on the machine, they say, oh, sorry, this image is now not publicly available. Please buy our subscription to get access to the image again. So imagine yourself like late at night, you have some kind of outage, need to recycle the nodes, and the database doesn't come up because they put the image on a private registry. I mean, one of the learnings we did, we never gonna fetch from the private registry again, and then migrated away to Cloud Native PG, I think. But long story short, the way how they recommend doing the installation with Customize is they have their base repository of the Crunchy Data operator, and you need to fork their repository and then customize it with patches on your for your environment. So, and if you want to have a new update of the Crunchy Data Postgres operator, you always need to resync the upstream and apply the patches and rebase it, and this is really kind of messy. And especially for package management and third-party packages, this is not something you want. I mean, also for your core platform, it's probably not something you want, but I think Dotan, where is he? Oh yeah, Dotan will talk about this in the next talk. So let's go away from Customize. I already said that Helm started in 2015 ago as a hackathon project, actually by the cloud native consultant company Deis Labs. It was back then in Helm version 1 a client-side tool. And in 2016, it got then merged with the, I think, Google-owned Kubernetes deployment manager. And Helm 2.0 was born with a server-side component, which was then called Tyler. They had, let's say, some of performance issues. Also, the community never really liked this kind of approach. So they rewrote it again. And Helm 3.0 was released 2018 as a client-side tool. And it's also one of the first projects that got accepted into the CNCF, and it's one of the oldest CNCF graduated projects. And although it's still around and still obviously the gatekeeper, it still also improves. So with Helm 3.8, it started the support for OCI images. So nowadays you cannot only download your charts from repositories, but you can also upload and install OCI image. It has some drawbacks on itself, but it's already possible to use OCI images with Helm. And let's also focus on what's the good things and why Helm was born in the first place, right? So manifests got really large, and we needed some kind of templating to get around with it. So Go templating was one approach. A lot of people already know Go, so it stick around. It offers like built-in variables, so you can your release versions, you can have like stuff like namespace deployments and so on, and which is like baked into Helm as a tool. You also have your place where you could put your custom resource definitions, and it gives us some kind of structure, which might help you if you're a novice developer. And it obviously stores all the revisions in secrets inside your Kubernetes cluster, where you then can roll back to different revisions. It has a theoretical concept about subcharts, and one of the most awesome things is like the artifact hub package registry is a great place to find Helm charts and also their default variables. But how does Helm look under the hood? If you have taken a look about the revisions, they store every revision of your chart as a secret. So what's inside the secret? There's the values, the chart name, the chart version. So you can theoretically roll back to this revision. But you also need to know that you will never be able to get the exact state of this revision, because Helm only has the information about the manifests and deployments. So if there is some kind of database or stateful application inside and has like some kind of stuff stored inside a pod or a persistent volume attached to the pod, you will not be able to roll back to this exact version. So you can only change between the manifests and all the deployments. And if you take a look at what's exactly inside the secret, or the kind of release stored inside the secret, it's base64 encoded. It's actually 2 times base64 encoded and then gzipped. And if you want to read the raw value of what's inside the Helm release, you need to execute this command, or you just can use Helm get values and then the release name of the Helm chart. So yeah, not sure why it's 2 times base64 decoded, but that's the way how I work it. And Helm obviously has some challenges. Like with every package author I talk, they all say Helm templating is the worst ever. Like using plain text formats to customize with some kind of Go templating language, your chart is like super messy. Most of the commits actually on some Helm chart repositories are about fixing bugs introduced to the Helm syntax. And we talked before about OCI images inside Helm. Yes, they are there, but you can't search them. There's no kind of, because the protocol of just this tar gzip OCI stuff thing is, and like searchable or meaningful mineable. And also one of the challenges a lot of people faced is that the CRDs that are put inside the Helm folder for custom resource definitions are not updated by default when you upgrade the Helm chart. So this is why a lot of packages either perform breaking changes, like the Kubernetes stack like bumps their major version every time they make a custom resource definition change, or they put it just inside the normal templates, so the custom resource definition also gets updated. And there's still some technologies out there, like the Flux Helm controller can do these custom resource definition updates, but you need to be aware of them. And obviously, one of the challenges, there's no simple Helm update. You need also resupply the configured values every time, else you will break your release. And why Helm isn't really recommended as a production tool. For example, there is a GitLab Helm chart out there, but it has so many dependencies and stuff inside this GitLab Helm chart that it actually states, yes, we have a Helm chart, but it's not recommended for production. Because if you install the plain GitLab Helm chart, I don't know, you'll get your own Prometheus, you get your own databases, you get your own Nginx's multiple times, registries, and so on and so on. So this is some of the limitations that have if you publish Helm chart and you're more than a simple cloud native application and have like real world dependencies as Captain has. Captain is a tool like sponsored or like mainly developed by the guys at Dynatrace. And it interacts a lot with the Kubernetes API. And in order to do so, it needs to provide SSL endpoints. And in order to get these SSL endpoints, they need to have a mechanism to get certificates or certificates. And for this, they use, obviously, Cert Manager. But they have a problem. Either they bundle Cert Manager inside their Helm release, and then the Helm installation will fail because the Cert Manager custom resource definitions are already in the cluster, or they don't bundle Cert Manager inside the Helm chart, and then the Helm release will succeed, but the tool will not work because certificates don't get issued. So what did they do? They forked Cert Manager, renamed every custom resource definition into the Captain Cert Manager resource definition, and now you have two Cert Managers, one which is still always running in your cluster, and one that Captain ships with you with their own custom resource definition. So also a problem from Helm because they don't support cross namespace dependencies and these are also some of the reasons why we started out Glasskube. And we just released our first version in February, so we're really fresh, but we really have the goal and the main target of becoming a viable package manager for Kubernetes. At the beginning, we don't want to reinvent the wheel. So we are still using Manifest, Helm, and other OCI images under the hood, but just talked with Victor, and because we are really curious about what configuration language we should use to create packages that are not based on Go templating. So he's a great favor of different technologies. We talked about Q, we talked about Starlake, and we talked about some of these configuration languages out there. I think also he's a big favor of KCL, so let's see in which direction we are going. One of the pain points we already solved or already defined is like dependencies between packages, dependencies between other operators, dependencies between Kubernetes versions, and all these compatibility checks. So inspired by Brew, we have a central package repository where we have an open source tool called Scout that scouts for new versions of these Kubernetes packages, performs automatic CI/CD tests, and then merge these packages into our main trunk or main branch and make sure these packages are available for end users after they completed their checks. So you get with Glasskube all the packages, tested packages have real dependencies, and with the latest release, 0.11, we just introduced cluster and namespace scoped packages. So some of the operators don't make sense to install multiple times, but some of the packages you actually want to install multiple times. So this is also something we can differentiate between cluster scoped and namespace scoped packages. And for all the bigger installations out there, also we do it internally. We provision everything with GitOps. We are already working on a Renovate integration. So the data source and the version scheme is already merged into Renovate, and the Renovate manager is getting merged as we speak. So it's still in development. But yes. So let's dive under the hood. How does Glasskube architecturally work? We still have a server and a client-side component. The client can be used either a CLI, which is written with the Cobra CLI framework, or you get a UI for which we use HTMX for real-time communication stuff is. You can also directly put every custom resource we generate against the Kubernetes API. Or you can use one of our clients to put it directly against the Kubernetes API, or output them to your GitOps repository, so you can manage the state with GitOps. After the Kubernetes API obviously receives the package custom resource, it will then fetch the package info from our central package repository or your own private repository. If you're like in an enterprise and want exactly control with packages are available for users, for your developers, for your internal stakeholders, you can also point it to a private protected package repository. And after this after the installation guide, how to say, is available, everything gets reconciled and we're gonna deploy the package. So I think we still have time for a short demo, and I wanna show you how Glasskube works in action. So for this, I'm gonna now mirror the screen. Let's see if it works and how fast the signal is gonna be picked up. Yes, this looks good. I already increased my font size, but is it enough? Big enough? No, right? I need to increase it even more. So this should work. So we're not gonna stop it. We're gonna start a fresh Minikube cluster. I just downloaded the Minikube stuff before, so it doesn't take too long. But if we take a look at what's inside, it should be completely empty. Yes. Still waiting until the core functionality is up and running. And and then we're gonna take a look at Glasskube. We'll be fine, we don't need containers. So the first thing we cannot check is we cannot check which version Glasskube is running on, and we see that the Glasskube operator, like the server-side component, is not yet deployed. So we can bootstrap Glasskube just with the Glasskube bootstrap command, which we're gonna install all the manifests in the all-in-one approach. We have two different mechanisms of installing and bootstrapping Glasskube. One could be the all-in-one approach, and one could be the slim version where we don't ship third-party components. As we still have a dependency on the Flux Helm controller, we're gonna ship the Flux Helm controller. So if you're already using Flux in your cluster, you can easily install the slim version. Perfect, genau. We're just gonna wait until the Helm controller and the source controller from Flux are available and the deployments are green, and then we can take a look at the Glasskube UI. So you could also bootstrap the UI via. You can also bootstrap Glasskube via the UI. So if I start the UI now, you see it's already there, but. Yes, all the pictures loaded, and Glasskube got successfully bootstrapped. We have a simple user interface where you can install basic packages. For example, we can install Argo CD. You can switch between different versions, and all the versions are there tested by us. And what we also have as a package manager, we want to also try to give our users the possibility to talk with each other, to have this kind of upvote stuff and all the social interactions. So we implemented Gizcast, so everything you comment here is, And we're using Argo CD at KCD Czech, and hopefully we are now also using it in Munich as well. I hope these comments get framed sometime. Perfect. Let's go to the CLI and look also what we can install. I'm also a fan of the Kubernetes dashboard. So let's install the Kubernetes dashboard. No automatic updates this time, and everything gets fetched and installed. And we also want to take a look at how we can actually use Argo CD in combination with Glasskube packages, because as I said, every Glasskube package is just a custom resource. So I provided some basic demo repository where we have a Captain package in a specific version. And the Glasskube Captain package has a dependency on Cert Manager. So once we install the Captain package, we will also then install Cert Manager. But let's take a look if Argo CD is successfully finished. This will take some time. Perfect. this looks good. So we now have Argo CD. We also have like port forwarding, so you don't need to take care about manually port forwarding. In the Glasskube package manifest, you can configure which services should be exposed, and then we automatically create the port forward for do. We just go into the current Argo CD context, get the Argo CD initial admin password, and then log in into Argo CD. Yes, a working Argo CD. Perfect. Next step, we want to install the Captain package with Argo CD. So I'm gonna make an Argo app create Captain from my Captain repository. So we create the app, and if everything should be ready, we're gonna see the Captain package inside Argo CD. So we just now we need to sync it. Just now we saw that the Glasskube custom resource got deployed into the cluster. The Glasskube package controller will now pick up the custom resource. It will determine that the package info will have a dependency on cert manager, and hopefully Glasskube will then create the cert manager names with install cert manager and link both packages together. So let's see if it works. Else we need to debug it, because we introduced a new flag in the custom resource, which is probably not yet there. So, oh no. Wow, should I do it? This is gonna get messy. Okay. Get logs, namespace, Glasskube system. It's not get logs, it's just logs. Okay, we cannot install the package via Argo CD. We're just gonna install it manually via, let's see if this works, via the UI. And then we see that the package has a dependency on cert manager, and cert manager will be then installed as a dependency before that. One of the other, while this is going to get installed, one of the other nice things we added to Glasskube is like package configuration options. So you usually have a lot of unstructured long YAML value files where you don't exactly know what to put in which place. So in our package definitions, we can explicitly claim how to configure your package, what values put in there. You can say, okay, you have a select value, you have some mandatory fields, and in the end, you can configure a package as you want. I think as time is running out, we have maybe time for 1 or 2 more questions. So we're going to have a look until packages are installed. And this will take some time, but I think we don't see it here, no, because it's a different package. Yes, we have some time for questions. So I'm going to put to the last slide. And I hope everyone got a brief understanding of how Glasskube works.
So my question would be, so I didn't see the manifest of the Captain thing. So yeah. You can basically, this is still possible to do a Git-based flow to deploy the stuff. You don't have to do it via the CLI or the UI, because yeah, I want to have it declarative in my repository. So this is the whole thing. This is the whole thing you need if you don't have any configuration options. And this version is actually then get picked up by Renovate, because with a Renovate Glasskube integration, create a pull request for a new version. And we are working on a Git bot that provides you additional information inside a comment of how widely available this version is and how likely it will be succeed. This is the only thing you need to deploy inside your GitOps repository. Okay, yeah, thank you. And the manifest itself is also located in a public repository, and this is how it looks under the hood. We have different manifests for the Captain, for Captain issuers, and stated dependency. And for more complicated packages, like Quickwit, you can also configure these input values
with options, and then the user can select. You also have some limited templating, which you want to get rid of soon, with a structured configuration language. One more question.
Hi, thank you for the presentation, sir. Does the cluster operator have any restriction on the repository which I want to restrict to pull packages from?
Pardon?
Does the controller has any restriction on which repository I want to pull packages from?
Yes, you can. We have a list of repositories you can configure Glasskube from, and you could add here some local repositories or internal corporate repositories with a specific authentication. So if I would add a local one, I can just add a local one, and then you have multiple repositories. And you can also configure it in a way that your developers cannot access the local repository, just the private one. Yeah, this one is not ready because it's not started, but yeah. Perfect. Thank you so much. And I'm here the whole day and tomorrow morning, so feel free to approach me and yeah, talk about package management and Kubernetes. Thank you.